Hello, this is the second series of the lectures regarding prototyping. There is a what do you call little bit of enthusiasm when somebody calls simple rapid prototyping as 3D printing or the other way. The issue being that we should first have an idea of how eventually a product is going to look like. And then if you remember last time I showed you that it is a sequential thing. So, if you look at my this slide here, one of the things you will notice is that it is long because of the long duration, looks essentially as a sequential process. It is not more than just being a sequential process, it is that the every previous stage of any decision making will influence a future step. Again, if for every future step which we may or may not have thought of, we need to get back to what we have started. So, this all this kindly have a look at this, sir, give me a picture of this. This whole thing has been taken from Product Design and Development from Ulrich and Eppinger, any edition. The edition I have is a little old, but this being an educational institution and the general common license, my suggestion is buy the book and read everything in the book. It is big, okay, closely typed and full of illustrations and unbelievable amount of detailing, including a tab on design for manufacturing. This is where my emphasis back on a little bit of advance working towards this is very critical. So, coming back to this slide, at this one point we have identifying customer needs, target specs, product concepts and select product concepts. Now, when we talk about a product concept, it is real that this is not an easy thing. Have a look at this mouse. They are all sizes, all shapes, they are very tiny ones, they sit well in the hand, there are some which are flat, and I am sure all of you are familiar with Apple's single button. There is only one small thing, a small what do you call a roller ball, and then whole thing you press and works, and then this. It is not easy. Whatever product concepts we are talking about, not easy to converge and come back to this again. Even a very routine thing like, all of you must have seen this, mobiles. Not long ago, a mobile meant all sorts of shapes and so on. Right now, it is flat and works more than anything else, it works, and almost all of them have camera now. Now, when you go to a shop to buy a mobile, first thing he does is he will give you a dummy device like this, saying you touch and feel it, see how it looks like. So, somebody has worked out, has gone to great lengths and worked on all these things here. You have seen this? Both are about the same display size, but then there is something here, something else here. These are actually identical. Now, this is where our whole issue of selecting product concepts comes about. Somebody has to go out of the way to test these product concepts. You see here, they are not easy, set final specifications. This is where we come to build and test models and prototypes. What looks very easy? Models and prototypes. And this is even before setting the final specs. Have you seen this? Then after that down we get everything, development plans and all that stuff we get below all these things. So, the reality is we need to make prototypes. Only when you make a prototype, you will know what next will happen and what to do. Now, we will see And the uses of prototypes are learning, communication, demonstration of a product for feedback. This product for feedback for both the customer, end user, ultimate end user, and all the people in between, including the manufacturing people. It looks easy to say, but actually tough. Not easy for anybody to understand something which is written. You can't just say, for example, if you see all these three prototypes which I have shown you, description looks about the same. Even there are numbers and sizes saying 5 inch, 6 inch and 5.6 and you have so many grams weight and all that. How do you make out all that unless you have a physical prototype? This is where rapid prototyping gets its fantastic cover and visibility, saying physical models of style or function. Now, these days if you go to any shop where they sell consumer durables, you can even have a beautiful big dishwasher or a clothes washer or things which are essentially closed, but then they want you to know what is inside. So, what do? They make a beautiful miniature working model of a transparent acrylic or something, and the secret is they are probably all made by rapid prototyping. Another one of the uses of prototypes is combination of subsystems into a system model, alpha or beta test, which I have explained to you. Beta is almost ready and the customer is given a chance to test it. Then when do we develop the testable hardware, final hardware? This is where our rapid prototyping seems to help a lot, because you see everything is very long. It is not easy to get into this thing at all. So, the next one I will talk to you, which I have tried to emphasize last time. It is not easy to have something, all the items a fully analytical thing. Not easy to put equations for each and every aspect of a product. And then you see here we want a comprehensive physical product. So, we can have all these final prototypes. Eventually everything falls in place, and to avoid the lot of time consuming, we end up with this rapid prototyping. Very much related to this is the moment you have a CAD model, you have the advantage of always going back and making things easier. Physical approximation of the product, that is what I was telling you. When you go to buy a mobile in a mobile shop, he will give you a practically identical piece like this. It will be, you know how well it feels, and you know what are all the keys, the keys are there, you know where the charging things, you know where the headphone slot is, and finally you know how well it nestles in the hand, how does it feel. It is not easy, and these days if you can somehow make a CAD model of this, a CAD 3D solid model, it is easy to change it. One simple thing is, if you want it to be squeezed widthwise, a small command, lengthwise yes, radii in the corners and thickness, and then what about these things. Fortunately for us now, using 3D printing, all this is possible. All you need to do is, if you have two things here, you see here I have two boxes, okay. Both of them are meant for my hearing aids. This is much smaller, this is a little bigger. So, there is a place here for once when they thought of it, they made place for batteries to be placed here, and then these hearing aids nicely sit in this. Now, subsequently when things became smaller and smaller, they found out it is much easier to have something which is very simple, and this is actually taken from a hearing aid thing from, I am sorry, not hearing aid, headphones thing from Samsung. So, you see here it is slightly transparent also. So, if I keep it here and shine something on it, I can make out if it is there inside. Very small, easy, handly, put it in the pocket, but then easy way it will also fall out. I will ignore that. When things become small, this touchy feely we have no option to, you see here, that is what now it says tangible. How do you touch? Approximation of the product, and may exhibit unmodeled behavior. You see here, in this case unmodeled behavior means something not as per the intended thing. One of the simple thing I can talk of it is, if I have shown you this whole what to say, anything which we need to write, any pen or anything, no, how well does it balance itself? Does it have something which center of gravity shifts, and there is a key here, and another is some behavior may be, this is the what you call this is the pro and then the cons. Behavior may be an artifact of the approximation. If you make things because of this, you see here the way it behaves, how do I clamp it? Do I hold it like this? And you see there is something here at the tip, in this case, no, this is a stylus. This tip helps me in what do you call, doing things, and on the other side they have given a dummy thing, both for the purposes of, I can point here, nothing will happen. If this whole thing were to be made in 3D printing, no, life would have been easy, absolutely easy. Only problem or anything is, how well is it balanced? Should the weight be a little to the back, or should the weight be a little to the front, and then how do things shift? This is where physical prototypes are getting better. Now, when we come to these analytical prototypes, typically it is a mathematical model. So, one of the mathematical modeling is that let us say if you have a flow, how well does water flow out of something. So, reasonable example is, I am sure you people have gone around seeing in the shops now, suddenly glass is back. For tumblers, for any other modeling things and all that, no, there is a nice way in which you can hold a glass tumbler. It does not look like plastic. All that thing saying something breaks, hence use plastic, seems to be going out of fashion. And if you have glass, it can be cleaned and lasts forever, brings you back to the good old milk bottles which are familiar. Suddenly the milk bottle is in everybody's attention. Here we have now mathematical model of the product. Simplest thing we talk about is, if you know the volume and then if you know the thickness, you know actually how much can we hold. In the case of the imperial and American thing, we have things like the gallon, the quart, the pint and so on. In case of our metric, invariably use the liter, and something part of it typically all our what you call cups and all that are about, a small cup is about 100 milliliters, a very large cup is 200, something in between is 150 ml. Now, if I have a mathematical model, it is a question of playing around with the diameter, height and the wall thickness. So, anything I want, if I want to make a 100 ml cup, I can make it, the same model is valid. And if I have anything else, let us say instead of being straight, if there is a taper, the cups can be stacked. Oh, you have a handle, something can we do such that the handle also can be used attractively. Then how do we stack them? Supposing we have this cup, now you need to pack it. For packing, how well do you pack 6 of them in a box or 2 of them in a box? How do you make a display, a merchandising device with a display thing? This is where rapid prototyping helps immensely. You can make the cup and we can keep one over the other for packing, or we can keep them side by side, or we make them diagonally, meaning imagine if this were the cross section of a cup. How about stacking them like this? Do they look better? Like this, or one over the other, one in front of the other. All these combinations, if you have a model, in this case analytical has been used exclusively to talk about something which is a mathematical model, saying you have set of variables which are large number of variables, and then you also have a set of eventual outcomes of it. For example, I have given you the very crude simple example of a cup which has a diameter and then a height by which the volume can be calculated. Using that we can also calculate the weight of the thing, how much material, and then I have also mentioned to you that if you give a small taper you can see how well they are stacked. Then analytical prototypes have the the disadvantage or limitation saying can exhibit behavior arising explicitly from modeled phenomena. Good. So, we have two liquids in a container, one of them is water, you know how well water behaves, and then water has been modeled so well. In fact, there are so many things like Prandtl number, and we all know there is something called a viscosity, we also know there is something which is a density, and we know surface tension, and how well water will pour out of something. Quite okay. Does honey flow as well? We know very well, yes and no. Then what about petrol? Does petrol flow out of a can as we assume? No. You would have found out in a very surprising way, if you take a can of petrol and pour, there is invariably a leakage outside. The same thing if you use water, there is not a leakage about it. I will let it go at the moment, but then I would like to say this behavior often it helps us. If it is modeled well, it will help us. Some behavior may be an artifact of the analytical method, meaning the analytical model may vary in a narrow range. If you go beyond that or combination, things may go beyond that. And then you see the most important thing at the bottom. I need to enlarge it and show you. When allow more experimental freedom than physical models, we just need to play around things very easily. If you have a geometric idea about how well something opens, so if you can show me this, sir. See, here I have a box here, and you see it here opens like this. Beyond this, there has been intentionally some stopper has been provided here. So, if I have a CAD model of it, I know where it stops, how much it goes, how much gap it is, and how well things close like this. See this is a clear advantage of, if it is a fully mathematical model, how much of force is required, how well it is closed. So, I am sure all of you have seen an automobile, the back hatch. So, if you open the hatch, there are two supports there. How much of force is required, how well do you model the support saying it is fully open, it should not fall down, and then after a certain point it should close shut, it should not dangle outside easily. So, we have a hatch which when it is fully open like this, when it is down here, and then if we know this and then the weight of the device and the shape, we can easily, we have the two gas filled what you call shock absorbers, loosely I will call it a shock absorber, it is just a support, seen that. Now, so if I have a proper combination of a mathematical model and combination of a physical model is what you see, and a CAD model, it is very easy for us now to come up with the dimensions of the gas stopper, gas filled stopper, you see. One of the things which are very common in your experience. Now, let me go to the next slide. This I am sure you would have tried as a engineer and more out of curiosity. There are two type of things. One of them is a simple focus prototype. I have given you an example of a hinge. How well does the hinge open? So, a focus prototype will talk about one specific question about the product, saying how well does the car door open, and advantage for us is we can easily show someone how well our idea is going to be. Advantage, it is very easy, very simple, and generally several are required, however no issue about it. Comprehensive prototype implement many or all attributes of the product. So, how well does so I have again this pointer. So, if everything it has a small switch here and so on, many are all the attributes of the products can be checked. Similarly, opportunities for rigorous testing, including what will happen if it dropped, how well does it slide into a cover. So, we have these issues of saying often best for milestones and integration. I will try to a sample. I hope I brought it along today. I think you know what these are. Both are backup batteries, also called some storage, or I do not know what is the name that is given to it, saying you can charge it. This one has probably good old lithium ion or nickel metal hydride things. So, it is a little thick, it is big, and some number like 1000 milliampere hours is written, and this one is the same one, except that it has thinner lithium polymer batteries similar to what you already have in your phone. So, we have here, you have seen this, advantage is if I now make a physical model of it and I will show you what all is inside, very easy for them to, what do you call, somebody to make all the necessary electronics. Where do you keep the charging devices, discharging devices, and do you have a switch, and can you now make a pouch? If you make a pouch, when I open it I can use it, when I close it, it will keeps getting charged. You see here, it is very easy for me. If I have a prototype of it, and this is an actual model, this is an actual model absolutely, I mean not model, it is just a working unit from the thing. Such things like this can easily be made out of 3D printing, it is very easy. And then you have noticed here they have put a little bit of graphics here, then they have put a switch also here, while in contrast this does not have any such things, it is intentionally made thin, because as I told you we push it into a pouch and there are various switches and all given here, including a charging thing and also. Obviously, this has a place, this has a place. Now, I will come to a more interesting and very commonplace thing. I am sure some point here that all of you have enjoyed using this camera. Imagine the amount of care that has gone in making this. It is so tiny and it has everything. I am surprised, it says a 10x zoom and it has a 15 megapixel what do you call thing inside and all that, and then it has a obviously place for me to put the shutter release button, and then I have a shuttle what do you call knob here, and then I have everything. Right now I will switch it off and I will come to a very critical thing, saying in this small thing there is a place for the battery. Somebody has thought about all these things. So, if you were to have, it is an expensive piece, this thing I think I have paid probably equivalent of $200, it is around 15,000 rupees long ago, this is about 3 years old. At that time it is, right now I think it is maybe around $50, same thing you can get. But you see a lot of thing has gone into saying this thin battery goes inside. Now comes the other option saying, what if I run out of batteries? Is it not logical that I make something which works with rechargeable cells outside? The moment we say rechargeable cells outside, we can talk about a AA or a AAA. AA unfortunately big, it is the whole form factor becomes big. So, what instead they have decided is, let us stick with the small what do you call small cells. Seen this is one of the very common thing which is used in all the cameras. This is a lithium ion cell, saying why can't we instead have a charger for this, which works directly from 230 volts, or also it works from your car charger. Or in the unlikely case, if you have an adapter, it is possible to for you to take any of these things, have it charge this, and in one of them the OTG cable from the mobile can charge this. Now we come to a very important thing, saying if the mobile is around, do you need this at all, which is true. Now these days people do not bother to carry this around, except that the quality and all is good. All this is now if you look back at my slide, best for milestones and integration, saying how well can we integrate all these features into the product. So, I said I would like to thank and acknowledge the original author of this. You have seen this, somebody has to check all this stuff, no. So, in this case both the combination of mathematical as well as physical models are done. Little scary to think of maximum loading, when will it break, where will it break, and behavior is almost predictable, very rare for anything to really go off. So, we have technical or market risk on this cost of comprehensive prototype. So, you see here, you can read the matrix yourself. When the market risk is low and cost is low, this book itself now, in this case it is not about so much about the contents, because contents are well known. It is more about the format, picture, how well it is. This is widely used in graphics and professional things. That is why books designed well sell well, and then after you open inside, even very carefully, somebody has chosen all these things carefully. Incidentally, this is a low cost edition, it costs a lot less, and not in color, but they all colored original hardbound editions, no. They are expensive, but they have also gone through extensive testing. The other extreme, we have high technical risk versus cost of comprehensive prototype. So, probably the development cost is probably equally shared by the developer and the customer. So, now you see here we have this packaging, which incidentally like war, for a lot of packaging testing, the cost of building a prototype is not big. You just need to put a cardboard and then put it, and even the content inside, saying how well do the serials behave. So, we have fantastic things about it, no. Of course, in this case it looks like saying it is a special a serial which will make people more healthy, but even the behavior of the cereal, that is, you keep it in a box and then if you pour it, how does it crackle. Secondly, how much of taste testing is important. We in parts of the world, we have a very complex taste. For us, normally sugar and salt, the combinations are very different from what other regions behave. But the thing is, duplicating a few hundred numbers, meaning take a few hundred kilograms of the material and reformulate it is relatively easy, because the market risk, if you do a mistake and you can't sell your product, it is a waste. And you go to the other side, technical or other thing, there is a beautiful ocean liner here, this extreme one, no, this one is an ocean liner. So, I do not know whether people say few are comprehensive, no prototypes are built. It is not really true, meaning for the all the superstructure, probably no prototypes are built, but individual small parts are built, cabin layouts and all. And more than that, if you see the design of this hull and the total volume displacement and the various weights and various safety features, all these things. Full comprehensive prototype is not built, but small models are made. You too would have seen in hydraulic slabs, you will have this what you call ship structure, probably scaled down 1:1000 or 1:10,000. It is kept in a what you call water stream, and it shows how well it behaves. Even waves and all can be shaped, including we have here one chimney. So, a full comprehensive 1:1 prototype is not built, but small things are built here, and obviously you cannot build a ship prototype of a huge ship or an aircraft carrier or anything, but they are extensions of earlier technology. As such, not a big deal. Here we come to the crux of the whole thing, how rapid prototyping and especially 3D printing has become very important, because it is part of the prototyping strategy. Prototypes invariably avoid surprises in the final product and in the market. The marketing people use it because how well the user experiences the product, and in the opposite side the formulators in the case of foods and all that and various other people use it, how well the thing behaves at all. So, a prototype at all stages reduce uncertainty or reduces surprise in the final thing. And here exactly are you making it for purposes of the market, are you meaning end user, are you making it for the cost point of view or anything, and you see here no defined purpose you decide. So, those what you call battery banks, where do you use it? Do you carry it with you? What should be the weight and so on? And multiple forms of prototype saying, is it going to be made in the final materials, or is it going to be a mock-up painted to look like the original? So, if I have time next time probably I will try to introduce some of the small things we have. I am sure you also would have seen food on display at the entrance of a restaurant. They are all mock-ups that are presented. They are saying this food is going to look like this, inviting, and you know what to call it. So, you will call a vegetable and maybe a squid, and finally what is the portion size you are likely to get for the price you pay. If you pay $100, $10, you know what you will get, and similarly for us, if you pay 100 rupees, we know what we will get. So, these are all display food items for the case outside, which we do not need it. I will try to introduce the pictures later. And you see here, early models are used to validate concepts. The next slide from University of Cambridge, I will show you, that will show you these things. Relatively few comprehensive models are necessary to test integration. Full comprehensive models are very rarely required, because if you see the inside space and all that, you probably will just be working with the inside items. Plan time to learn from prototype cycles, avoid the hardware swamp, saying once you get into the what you call quicksand, saying this hardware is fixed, we are in for it, absolutely, there is nothing you can do about it. Now, this is probably you should have, I am sure you will be wondering, sir, why did you not get to rapid prototyping first, or I am eager, I want 3D printing. So, before you get to 3D printing, and before you know why some of the 3D printing problems, you should know why all this prototyping is required. So, in the most of the rapid prototyping model now loosely called 3D printing, most of these methods are additive rather than subtractive process. Often you see here 3D printing, lot of them are there, 3D printing is only one of them like that. So, you have molten plastic which will go on building things, and then you have your eventually your prototype. So, we have, you can make parts in layers based on a CAD model. If it is a 3D solid model, you know how to make it, and if it is a what you call surface model, you know how it is going to behave. Then we have all this selective laser centering and all, which will come back to the thing. In passing, I will show you what these things are. Then laminated object manufacturing, and so many are coming up every year. So, hopefully, so we have this 3D CAD models enable many kinds of analysis. This is where we have the advantage of, you can use the same model for other what do you call, one of the thing is how well do two parts assemble together. If it is a snap fit, how is it? Then manufacturability, can we manufacture them? Then as I said, form and style, I was what you call emphasizing to you about the way those battery banks work, feel in the hand and how the mobiles feel in the hand. Kinematics means how well, how do things open, how much of things to this thing. Then finite element, method of finite differences and all meant for physical stress and thermal stress, how are things going to get hot. Then again crash testing. So, I am sure now some of us we feel how important safety is, and occasionally they will show you perfectly good looking cars being crashed into stationary walls, and beautiful expressions are called being totaled all in a matter of seconds, and then we have those dummies. You have here, it is old, I have seen that, 20 years old. We have a virtual crash test. This whole thing is just a simulated mathematical model about just about at the turn of the what you call in the 1940, automobile bumpers were thick, heavy and big and chrome. Suddenly they have found out if actually have a chrome bumper like this, you may be passing on all the shock into the remaining thing and hurting the unfortunate occupants. No more are rigid bumpers made, all the bumpers are crushed. So, during the impact, lot of the impact energy is taken by the crush of the various items that are inside. While it is dramatic here, even things like if you see your styrofoam or thermocol expanded polystyrene EPS packing material, you see it is not a solid, it is usually there will be small ribs, the whatever is needs to be packed is kept packed into a small space. So, if this were to be protected, it will be kept into there are enough cavities, and in between there are walls, which in case something falls, those things crush and nothing happens to this device. So, the device comes to be safe. So, whenever you buy such things, it is very unlikely that you will ever have any damage anywhere on these items, because they are packed, I mean what you call packed well, and the packing is partly by physical testing, and now it is almost a CAD model. If you have a CAD model, it will show you where all, if you were to drop the whole box into a corner, if you were to drop it onto a corner, how well does it roll and fall. And we have all, I think you have seen about, the cat falls on all the 4 feet all the time. How does it do? Only I think last 5 or 10 years the modeling was done, it was solved, saying somewhere in the midriff it is flexible. So, it is able to give a curve and then rotate itself and land on the things. And then in case you have a bread, which is buttered on one side. So, Murphy's law, or I do not know who found it, I am sure all of us found it. When it falls with the bread, with the buttered side down. Now, one of the wags, if you see the cartoons, has put one of these what you call bread with the thing, tied it to a cat, and he now wants us to figure out which way it is. So, I leave it for you. I am of the belief that first of all it is a waste to waste both the cat as well as the bread. other buttered toast and secondly the cat is wise enough, it will land on its legs and probably it's wiggle and do everything to spoil your test and probably it will throw away the toast. Leave it. So, we have here the virtual crash test. Traditional prototyping were easiest to do CNC machining out of a solid, and the solid can be solid metal like you can have aluminum, or it can be made out of other plastics. And we had this also rubber molding and urethane casting, saying if you make a positive model, it is possible for you to convert it into negative and then try to pour materials inside. So, traditionally people were taking wood and carving it, and even wood has been used in CNC machining. If you use a proper what you call cutter, it is possible for you to make something of any shape. Same thing is out of foam. This foam can be any rigid foam, very peculiarly polymethyacrylate foam, one white substance was used by industrial design people to make beautiful unbelievable models, really unbelievable models, and after the painting and all that you can't make out what it is. Then we have all this plastics, means you can take polystyrene or you can make PVC or you can make anything and then try to do CNC machining or cutting. This need not be what you call explained to you. Model making, there are highly skilled model makers and these people make models for industrial prototypes and also for architecture, and sometimes when the photograph is made and presented to you, you will be thinking that is the works, that is real. This is how the actual thing looks. So, I will I have come to the end of this session. I will just try to, this has been taken from the University of Cambridge Better Product Design Resources, which comprehensively covers what has been put in the other one. So, I will continue this in the next session. So, thank you.